Ladies and gentlemen, it's my honor to be here to update with you the current status of SF-TSV infection in Taiwan. This is Wei-Li Hsu from National Zhongxin University in Taiwan. Severe fever with thrombocytopenia syndrome, short as SF-TS. It is an emerging tick-borne viral disease identified in 2009 in the rural area of Hubei and Henan province in China. It is a life-threatening disease associated with fever and thrombocytopenia. It is caused by a tick-borne virus, SF-TSV, classified into genus virus in Phenylviridae. The viral genome composed of 3 segmented RNA genomes, S, M, and L. SF-TSV can infect both human and a wide range of animals. Tick is the main vector of SF-TSV. Previous studies suggest that the major vector of SF-TSV is Haemophilus longicornis. And this virus circulates between animal and have a tick vertebrate and tick cycles. In addition, human-to-human transmission through blood and respiratory secretion has been reported from China and South Korea. Since its first discovery in 2009, the number of SF-TSV cases has increased significantly. It has spread to the province in the center and also northeastern China, and even to Xinjiang, with a current face fatality rate around 6 to 30%. And SF-TS is endemic not only to China, but also to South Korea and Japan. In South Korea, the first SF-TS case was respectively confirmed in 2013. Since then, the number of SF-TS cases in South Korea has risen rapidly. From 2013 to October 2017, in total, 95 cases were confirmed, with fatality rate around 20%. And up to the present, over 1,000 SF-TS cases has been reported in South Korea. Of note, Jeju Island had the highest infection rate of SF-TSV in the country. STSV is a vector-borne disease, and a study based on Jeju Island has indicated that the incidence of STSV in patients was associated with the month infection rate in tick. In this chart, black line indicate the month incidence of SF-TS in patients, and the gray bar indicates the monthly SF-TSV infection rate in tick. The first case of SF-TS was identified in Japan in 2013, and it is chiefly reported in the Western Japan so far. Up to now, in total of 517 confirmed cases, with fatality rate around 13.5%. In addition to the 3 countries aforementioned, in 2019, based on a retrospective study, SF-TSV infection was first confirmed in Vietnam in recently. Apparently, SFTSV is not ended. Very recently, re-emergence of SFTSV in Jiangsu province is reported. Due to the high fatality rate, heavy disease burden, and lack of a licensed SFTSV vaccine, this disease has poses a great threat to Asian countries. As Taiwan is surrounded by these SFTS endemic countries, particularly only a strait apart from China. And in this figure, the SFTS endemic country was highlighted in red. And we could see that the route of migratory bird, showing in green, has passed through Taiwan. Accordingly, it is instinctive to speculate that Taiwan is located at high-risk region of SFTSV invasion, which urges us to investigate whether SFTSV has invaded Taiwan. Considering SFTS is transmitted by ticks, a free-range form in Nantou County was primarily selected for the surveillance of SFTSV. In total, 31 sheep, 63 beef cattle, 57 dog serum sample, as well as 360 ticks infecting bovine were collected for detection of SFTS infection by means of ELISA and real-time PCR for the purpose of seroprevalence and infection rate, respectively. First of all, the ELISA result indicated among the three types of samples, only sheep serum showed positive results. The seropositive rate is about 38.7%. Secondly, RT-PCR targeting viral NP genes was set to determine the infection rate of SFTSV, and the expected amplicon size is around 346 base pair. Overall, the SFTSV RNA was detected in 29%, 4.8% of sheep and bovine specimens, respectively. Moreover, 9 out of 36 pooled tick samples were detected as SFTSV positive. Sequence of the 20 positive samples with strong signal were further isolated and identified. Overall, the sequence share high similarity, and only a few variations were found in the SHIP1 and SHIP10 sample. Of note, sequence amplified from TIC2 shows 12 nucleotide deletion in the S segments at position 346 to 357. The 5 distinct partial S sequences identified from animal and tick indicate high similarity and were clustered in the same clade. It suggests a close phylogenetic relationship and a likelihood of circulating between the ruminants and ticks. Moreover, we also identified the sequence of full-length S segments from one sheep sample. Phylogenetic analysis indicated that our SFTSV was clustered into genotype C4, which is closely related to a Japanese strain, and in the same clade which consists of strains isolated from China in majority. In summary, SFTSV was detected in animals, ticks for the first time in Taiwan, and the seroprevalence of SFTSV in sheep was around 38.7%. The RNA was detected in sheep, bovine, and ticks, with infection rate was about 29%, 4.8%, and 25% respectively. Moreover, the local SFTSV isolates was classified into genotype C4 and closely related to the strains isolated in China, South Korea, and Japan, with 94 to 97% similarity. While our manuscript is under reviewing by EMI, the first human case of SFTSV in Taiwan was confirmed by our local CDC. And the human study report was published recently in Emerging Infectious Diseases in July this year. Our CDC confirmed in November 2019 a 70-year-old man who lived in northern Taiwan and had no travel history was admitted to the hospital with a 9-day history of fever, chills, vomiting, and headache, and had a generalized rash over the trunk and both feet was noticed. Laboratory examination shows that the patient had leukopenia, thrombocytopenia, and abnormal prothrombin time. As the patient often spent time on a vegetable farm in a mountain area without wearing shoes, it raised suspicion for SFTS infection. As evidence with RT-PCR, immunofluorescence assay, and viral isolation, our CDC confirmed that this is the first human case infected by SFTSV, and the highest virus load was detected on the day 12 and was decreased to under detection level on day 29 after the disease onset. Phylogenetic analysis shows that all the 3 viral genome segments of SFTSV belong to genotype B. It is worth noting that the S segment identified in tick from free-range form in central Taiwan was classified in genotype A over C, and the human case is grouped at genotype B. The distinct genotypes indicate multiple viral strains circulating in Taiwan. After the confirmation of human case, very recently we visited the farm where the patient used to visit in Taipei, and 1 species of tick was collected for further investigation. It turns out SFTSV positive, and the sequence alignment shows that high frequency of variation between the 3 set of sequence identified from sheep, human, and the tick collected from the human visit farm. Due to the limited quantity of tick specimen, we have been struggled to acquire full-length viral sequence. To conclude what we got so far, in Taiwan, human and animal of SFTSV infection were confirmed in 2019. Although the major tick vector species has not been documented in Taiwan, the SFTSV RNA was detected in other tick vector, and high frequency of sequence variation indicated. It's possible several genotypes of SFTSV virus are circulating in Taiwan, and the presence of an emerging SFTS case highlights the need for further studies of the prevalence, geographic distribution, and surveillance of SFTSB in Taiwan. Further study on identification of natural vectors and routes of transmission are needed. We would like to thank scholar from Japan, that is Dr. Shimoda from University of Imakuji and Maida Sensei from NIID, and also the SFTSB team in our university. Without their help, this study cannot go that far. And thank you for all your attention.